Hi, this is Rakesh Gupta, and this is my take on question 3 of end-term video assessment.
Okay, so let's start by talking about what is given in the question. So we have the OD given as y double dash plus 25y is equal to 24 sin t with the initial conditions as the initial value problem. So we can clearly see that this is a linear second order non-homogeneous ordinary differential equation. This is ordinary. So now, the solution for this for a linear second order non-homogeneous ODE can be given as a linear combination of two solutions. So if we consider y to be the solution of this ODE given in the question, so we can write this as a combination of yp plus yh, where yp is called the particular solution and YH is called the solution of the homogeneous part. The homogeneous part over here is y double dash plus 25y is equal to 0. Now we start by finding out the homogeneous part. So we assume y to be of exponential type. So just gonna write it as e power lambda t. So therefore y dash will be when you differentiate y with respect to t, you will get yeah. So when we substitute these values in in a homogeneous part, we are going to get y is e power lambda t, as we have assumed it to be equal to 0. So as e power lambda t, an exponential function, it cannot be 0. So therefore, lambda square plus 25 is equal to 0. Now solving for lambda, we'll get it as plus minus 5i, where I is also referred to as iota, the value for which is this is minus 1. Okay, so when we compare it to the general form of a complex number, which is a plus or minus ib, so we can write lambda as 0 plus or minus 5i, where a is 0 and b is, just going to write it, a is 0 and b is 5. Okay, so now the solution for the homogeneous part will be given by e power, sorry, not alpha, it's a, e power at multiplied with a cos bt plus b sin bt. So we know our values of a and b. We just substitute it over here. We know that a is 0, so this will become 1, as e power 0 is 1. A cos phi t plus b sin phi t. So we have the solution of our homogeneous part. Now coming to the solution of coming to the particular solution. Okay, so for our given ODE, which is y double dash plus 25y is equal to 24 sin t. Just a minute. Now for the particular solution, we are supposed to get the left hand side of this term of this equation, sorry, in terms of something sine, so that it cancels out with the right hand side. So for that, after applying the basic rule, the basic rule, we get this the general solution as y is equal to a sin t plus b cos t. Now we'll differentiate this with respect to t. Again, differentiating with respect to t. Now we substitute these values into this equation over here. So we'll get uh, sorry, we'll get y double dash as, then substituting y, which is equal to 24 sin t. Now we are going to compare the terms on the left hand side and the right hand side of this equation. So we compare the sine terms at first. So there is this sine term, this, and this on the right hand side. So we basically have 25a minus a equal to 24. 24a is equal to 24. We have a is equal to 1. And comparing the cost terms on the left hand side and right hand side, this is one of the cost terms, this is one, and on the right hand side there is no cost term, so I'm just going to write it as 0 cost term. So there is 25b minus b is equal to 0. 24b is equal to 0, which gives us b is equal to 0. Now uh, we have found out the values of a and b. We put this in the equation what we have assumed after applying what we have got after applying the basic rule. So we get yp, the particular solution, as a sin t plus b cos t. We have a as 1 and b as 0, which will give us sin t. So this is our solution for the this is our particular solution. Now we as you know, as you can recall, this equation over here, the final solution is going to be the sum of both the solutions of the particular and the homogeneous part. So the solution of homogeneous part we have got as a cos phi t plus b sin phi t. Just going to write that down. A cos phi t plus b sin phi t, and I'm going to add the particular solution to it, which is sin t. Now, as you can see in the question over here, we have the initial values as this: y of 0 equal to 1 and y dash of 0 equal to 1. Just going to write this down over here. So we will substitute these two values in this equation to get the values of a and b. So when we do that, first I'm going to substitute 0 in the equation as it is. 1 is equal to a cos 0 plus b sin 0 plus sin 0. Now sin 0 is nothing but 0 and cos 0 is 1. So we get a is equal to 1. Now we'll differentiate the equation with respect to t. Then we'll get, sorry, now we substitute this value in this equation over here. So then sin 0 is 0 and cos 0 is 1. So and like this is 1 is equal to phi b plus 1. Then we get b is equal to 0. So now we have the values of a and b, and we substitute that in this equation right here. Then we are going to get it as y is equal to a as 1, so cos phi t, we have b as 0 and plus sin t. Now this is our equation of motion for the mass spring system. Now coming to the part where we have to sketch the graph of the solution. So now I'm just going to draw the x and y axis. So we have so the period of our functions sin t is going to be 2 pi for sin t, and the period of the function cos phi t is going to be 2 pi by pi. So this means nothing but that when sin t completes one oscillation, cos phi t would have completed 5 oscillations. So first let us draw the graph of sin t. So if this is one oscillation, this is considered to be one oscillation from here to here. This is 2 pi. So in this time, there are going to be 5 oscillations of cos t, which are going to go like this. It's going to start from here. 1, 2. So basically, what happens over here is that the graph follows the sin t function. like on a general scale, but then these lines is what represents the actual graph. So there are going to be 5 oscillations in total. This is 1, 2, 3, 4, and this is the fifth one. I'm sorry, the drawing is quite bad. So I'm just going to draw it in a neater way over here, what it would look like. This is 1, 2, 3, 4, 5. So this graph, it continues to go like this. So it's basically following the sine curve, if you can understand what I mean. This is what I've understood from that. And now coming to the graph of yp. So we know that yp is nothing but sine t. So the graph of sine t is very simple. This is with the period 2 pi over here. Yeah. So that is all.